Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast again, back with another article review. In this review, I want to talk about a paper looking at the issue of reorganizing our behavior, reorganizing our coordination in the face of changing constraints. Of course, in the ecological approach, right, we accept that behavior emerges from depending on it through self-organization process, which depends on the constraints we face, the task constraints, the individual constraints, the environmental constraints, which are always changing, right? So skill is not a process of learning one thing and just reproducing it over and over. It's almost more of a maintenance, right? You have to keep an effective movement coordination solution in the face of an ever-changing environment, right? So it's about adapting, reorganizing in response to changing constraints. So what I want to look at today is a study that golf putting that looked at this specifically by Querso and colleagues, looking at reorganization of golf putting in response to changing task constraints. So the background for this study, as I kind of set up already, they recognize that in golf, there's a bunch of different information sources you can use to recognize affordances. Well, whether you can go for a long putt or you need to lay up or what the green is, right? There's visual information, auditory information, haptic and tactile information, and so on that specify properties of the environment you can use to control the putting behavior. One of the critical things you're going to need to do, right? And this was laid out nicely by golf coach Dave Peltz, recognizing that there are a very large number of variability in the task constraints in golfing and the environmental constraints, of course. You have different angles, slopes, trajectories, weather conditions, distances, right? So one really interesting question to ask is how do we organize our coordination solution to respond to these changes and constraints? Right. This has been looked at in quite a few different studies. I've done, in fact, some of this kind of work myself, related to the pressure work I was doing, several years ago. So, for example, Sian Bilak and I did a study of golf putting, and we looked at it. We had people putt from different distances. So, one of the key things I identified when I jumped into this research is that there wasn't enough changes in task constraints, right? A lot of the pressure research, people were doing the exact same putt over and over. So I started varying people's distance. So we had to kind of 1 to 4 meters, depending on where they were putting from. And we measured a bunch of the kinematic variables, and we found kind of very distinctly different control strategies, right? So as you increase the putting distance on the left, here is an expert, their amplitude of their downswing increased. So essentially, to putt longer, they were using a longer putting stroke. The other lines on here are showing you can mess this up by getting them to turn their attention internally, right? By putting pressure on them, they start losing this strategy. Novices on the right here, they're much more flat. So if you plot downswing amplitude versus distance, it's much flatter graph. The reason is they don't really vary putting length of the putting stroke as much. The way that they tend to control putting distance is by controlling velocity, right? Um, or having a relatively small difference in the putting length of the putting stroke for different distances, right? And Dave Peltz pointed out nicely the problem with this, right? And I talked about this in my book. The problem with this strategy for novices is it requires a ridiculous amount of precision, right? You have to there's no kind of room for error in the length of the backstroke when you're using a very small variation in one to control distances from 1 to 4 meters, right? So these are examples of a control strategy, a control law changing. In this case, what we're changing is not the information we're using in our control law. We're changing the movement variable we're regulating, right? Which personally, I consider that to be an education of intention. I lump it under that category. So we're not changing the information. We're not really changing the calibration. We're changing what we're actually controlling about our movement, right? And in our studies, we've looked at various different things: the velocity, the impact force, the angle, and it seemed like the amplitude of the downswing and the movement, and sometimes the movement time is another variable that people control. So that's some of the examples of some of the previous research that's looked at, simple changes in constraints, this distance, how does it change? And of course, important point about this is very discrete work, right? So we're getting 10 putts, we're taking your average downswing amplitude. right? So we're not really looking at how the change is evolving over time, right? We're just trying to categorize it by one variable, which has its limitations, as we'll see. So what they wanted to do in this study was look at how golfers reorganize the putting stroke in response to task constraints. In particularly, they wanted to look at when you continuously changed constraints. So if I move you from one distance to another distance to another distance, how are you going to continuously adapt and adjust? And so they're going to look at more of a continuous time series process rather than a discrete, like is done in past research like mine. Okay, so that's what they were looking to do. So they had 10 male golfers. They're all highly skilled. They played in Portugal for the Federation National Championship, a handicap on average of 2. They used a device called In Putter, which is basically an instrumented putter, right? So it's a putter that's very similar. I've used one of these before. Very similar, or something like it. It's very similar to a regular putter in terms of weight. There's no wires coming off it, but it has equipment inside that we can measure the movement of the putter itself, your heart rate. There's actually heart rate sensors in the grip and things like that. So they used all this kind of variable. They had people putt from different distances. So they had them putt similar to the ones that I used in previous research, between 1 and 4 meters. Importantly for theirs, what they did much differently than what we did is they had 120 trials, and they had people move between the putts. And they were as interested in what was happening kind of between the putts as they were, during the putt, kind of what was changing. They broke the swing down into kind of standard 4 phases everyone does: backswing, downswing, impact, and follow through. And they looked at a bunch of different variables. Again, common ones we use: amplitude, velocity, acceleration, impact force, etc. And of course, the heart rate, right? So they're measuring all these variables in response to these changing constraints. Okay. What they did was, I said, they over time they looked at time series, right? So they're measuring, for example, the angular velocity, right? Or the trajectory in the different angle. And if you can't see that, for those just listening, you get a graph where you have these kind of peaks going up and down representing each putt. And there's some variables that you look at are quite regular, right? As you move from putt to putt, you get kind of very regular increase in velocity, then a decrease, right, when you're putting stroke. But there's also some aspects that look like they're changing over time, right? And there's kind of aperiodicity, so there's some things going on where not only there's basic kind of invariance, right, in terms of the putting stroke, but people they're changing something in response to the changing task constraint, the distance. Right. So you can see this. Here's a bigger picture of this, right? And so for those that are watching, if you look at the trajectory in the z-axis, right, you can see kind of overall some basic effects, but also some changes going on with distance, right? So this is what they're looking at. The main measure they used to kind of try to capture adaptation in terms of these task constraints was one I've talked about before on the podcast: approximate entropy. So entropy, you can think of as, it's a measure of how predictable your movements are, right? So if you have highly predictable regular movements, right? So if it was putting like a metronome, the same exact stroke every time, I'm going to have very high entropy, right? Very low entropy, right? Is regular and stable, right? We can get the entropy as a measure of predictability. If it's on the other end of the spectrum, right, it becomes more chaotic, less predictable. For example, one of the things we found in studying pilots is entropy changes with pressure, right? The entropy of your gaze behavior changes. So it's a really good measure, especially when you're looking over time series, right? So what did they find? Well, first of all, they found some really interesting effect of the heart rate, right? So they found that heart rates change with distance, right? So putting distance, and also heart rate tend to go down. Interestingly, as longer distances, right? Well, there wasn't like a clear linear pattern, but you can see between the shortest distance and the next distance, you get a decrease in heart rate. So it may affect kind of the workload and attentional focus that's being involved. They also got differences between each putt, heart rate went down over time with practice, and kind of during the phase, heart rate was low during kind of the planning of the putt, went up during the actual execution, then back down. Right, so they got some interesting measures of here of kind of the adaptation to the putting environment. What they find with entropy, some of the examples, some of the things they found were kind of there was a clear pattern. So what we're looking for here, and the simple thing we hope will come out, and what I was hoping in the previous research, is that you can find some simple relationship between some aspect of the movement and some aspect of the task constraint. Right. So, for example, we found that downswing amplitude increased systematically with putting distance. Right. That allows you to kind of get a simple control law. They found, it's a bit more complicated than that. When you start having people switch from putt to putt to putt distance, they found some variables, for example, the linear trajectory on the z-axis, which is z-axis is the one going to the hole. So that's the one going to affect distance. So not surprisingly, you get a kind of a systematic change in entropy when you look at that aspect of the movement. Other ones, you get no real consistent pattern, right? So kind of the bottom line here is what they found is, you know, you can establish these kind of control laws, but there's obviously much more complexity going on in terms of the adaptations involved. Okay. So, we as a golfer, you need to continually regulate force, velocity, and acceleration, and to satisfy these different constraints. We have control laws. As you add kind of real putting instead of off a basic green where it's the same exact trajectory every time. You can see you're getting more complex adaptations, not a simple control law with one variable, right? That's kind of what we would expect. And they emphasize also the main kind of practical implication, obviously, of this is adapting to these constraints and reorganizing is obviously a major part of being a successful golfer. So we need to encourage this in practice, right? By exposing, the only way you're going to learn to adapt to changing constraints is if you face changing constraints, right? By having more variability in practice. So again, they emphasize this. So overall, I think this is a really interesting paper. I think it's a start at getting a more broad look at, and a kind of more look at a dynamical time series way of looking at adaptations to constraints rather than the very discrete way people like myself and others have done it in the past. So I think it's a really interesting way to do this, and I think it'll be interesting more when you add kind of the other changing constraints as we go forward. So that's it for now. Thanks for joining me, and cheers for now.